Okay. Hey everybody, welcome back. I might have lost the recording for the first part of class. I'm not sure. Camtasia's, we'll see. I saved it, and now I can't reopen it, but I don't want to spend time doing it now because now it's time to learn about other things. But yes. Although all we really did was see some pair programming and learn about Travis and stuff. This is probably the most important stuff that we'll cover tonight. I can always re-record this if something gets lost. And really all we're doing is reading a bunch of documents right now. Okay, so we saw Project 1 last week. That was the beginning of your multi-phase project for the course. And I sort of dropped some hints about like, oh yeah, right, and there are more requirements. We'll talk about them next week. Well, now it's that week. So let's talk about the requirements for testing your projects. So, I've been showing you test-driven development. And in test-driven development, you write unit tests for your code. And this is just how software is written now. 20 years ago when I entered the profession, it was still kind of new and kind of like, oh, I don't know, why are we having our people, why are we paying our developers to write tests? And people now realize that no, this is all part of writing software because you get higher quality faster, right? Unit tests give you that rapid feedback loop, which gives you the confidence that yes, you're doing the right thing, and that as you make changes, you haven't broken anything that used to work. So testing gives you a number of benefits beyond the rapid feedback loop. It also lets you be the first user of your own code. Are things named sensibly? Does the code sort of fit together? Anyway, because when we didn't have this, we had all sorts of problems. Not only just the long feedback loops, but oftentimes there was a lot of heat loss to friction on teams where you had one person testing and one person developing and they didn't agree what was going on. And it's like, I wrote that code 3 months ago. What do you mean you're telling me it's wrong? That's not right. It should work this way. No, there was all sorts of stuff like that. But things are different now and things have changed. And I want to make sure that you have an opportunity to experience the healthy way to develop software. Don't think the only way to develop software is just sit there in your cave and hopefully someone else will find all the bugs. No, it's up to you to make sure that your code works as expected. And actually, it's especially important that people who are early in their careers demonstrate that they know that they know what they're doing and that they can produce good work. And testing is a great way of doing that. So, because automated testing is so important, it's such an important part of contemporary software development, one of the requirements of your projects is that you author unit tests. Now, I've talked about unit testing for many, many years, but I've never taken this step. So this is an experiment, and we'll see how it goes this year. So when I grade your projects. I will run a command that will execute your unit tests with a code coverage tool called Jacoco, I think which is for Java code coverage. That I showed you this last week, but I wanted to run through it again. So if we go into our student and we say maven -p grader clean verify, that will go and rebuild the whole project from scratch. It'll compile the source code. It'll compile the unit test. It'll run the unit test. It'll run the unit test with code coverage on. And it'll tell you how much of your source code has been exercised by those unit tests. And it tells you, let's see here, all checks have been met. Somewhere here it gives you, I thought it would give you a report. Maybe it just doesn't. Maybe it just says that, look, all the code coverage checks have been met. If we go and look at the airline, which doesn't have as much, doesn't have as many unit tests, I believe this one fails, or at least I hope it fails, so we can just see what it's like. Yes, this one failed. Okay. Right. So it issued a warning saying, hey, listen, it expects the minimum ratio, so the minimum amount of code which is exercised by your unit tests is 60%. So 60% of your code ought to be exercised. The current unit tests only exercise 25%. So for a number of years, I've sort of been thinking, well, shoot, I want to encourage students to write unit tests, but lots of people out in the real world say, oh, you shouldn't be measuring code coverage isn't quality, blah, 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 which is true. But I don't know of a better way, or I don't know of another effective way of, let's face it, forcing you to write interesting unit tests. I could count the number of tests, but then you could just write, assert true, assert, right? I'm not going to look at your code. I actually, I want you to have the experience of either doing test-driven development, which kind of guarantees that you have good test coverage, or if you choose not to do TDD, sort of experiencing what it's like to then have to go back after the fact and try to figure out what exact test case do I need to write to exercise this piece of code. So anyway. You can run this yourself. I encourage you to do so. And so then I expect, and a small portion of your grade will be based on the code coverage of your unit tests. Let's see here. Yeah. And because this is the first time, because it's an experiment, please let me know. So if your finding is oh my god, 60%, I can't, that's impossible. I can't do it, and here's why. Let me know, and we'll talk about it. But I think you're up to the challenge. We'll see. But at least it's something that we can say, very distinctly, whether or not you've met that threshold. Any questions on testing? Any expectations are there? No? Okay. Documentation. So, code communicates a lot, and well-written code communicates a lot. When you use good variable names, when you use good method names and class names, this tells the reader of your code, which is very often yourself, a lot about the intention of the code, a lot about what the code is supposed to be about. But there are other things. There are other ways of conveying what your code does, and so documentation is a part of the course. It's something that I expect, and something that you'll be assessed on. So there are two primary ways that you document your code. The first one is called a plan of attack. So starting with your first project. You'll be required to send me an email 72 hours, so 3 days, so basically Sunday night, before the assignment is due, that describes what your project, a design document for your project. It's what is my project going to do? How is my project going to do it? Please send me a text email. Don't attach PDFs or anything like that. That says, okay, here's how I'm going to implement your project. And the POA is worth 1 point of your project grade. So anyway, and please, in the email that's sent to my PSU account, please put the letters POA in the subject. I have a filter that puts it all into a folder that I then, it makes it easy for me to grade and make sure that your other emails don't get lost in the whole stream from 40 plus students. But because all the POAs are in their own mail folder, don't send me an important, I'm going to miss class this week, POA, in your subject, because then I won't see it. And late POAs, you don't receive credit for. So, please do it. And of course, the very transparent goal is that I don't want you starting assignments at the last minute. And so 1 point out of your grade is determined on Sunday night. Because I want to make sure that you have an opportunity, that you take the opportunity to think and then also write about your project before digging in. So that's what the POA is all about. Any questions about that? Design documentation? Okay. The other mechanism for commenting your code is Java doc comments. So part of the language? I think so. It's part of Java. Is that you can have a special type of comment in your code called Java doc comments that describe the program element that follows it, so before a class or before a method. And this comment you can have some tags in it and stuff like @param and @throws, which this tool called Java doc can read and then turn into pretty documentation. If Follow this easy-to-use URL on the Oracle site to find out more about it. And I'll show you some examples in a moment. JavaDoc is important, and as a matter of fact, the assignments, one of the test cases in the assignments, I go through and I extract all the JavaDoc comments, and I expect that, maybe I probably say this later on, no, I guess I do. I expect that all of your classes and all of your methods have JavaDoc comments that you've said, okay, yep, here's what my class and my method does. And so there'll be a test case there, and that'll be part of your grade. Now, the other thing that I strongly encourage you to do, but since I don't look at your code, I really can't assess you on it, or I really don't assess you on it, is adhering to the style guide for writing Java. Code is shared, right? I mean, in the 21st century, code is out there for lots of people to see, and really part of your job as a software developer is making sure that not only your code does what it says it's going to do, but you make it accessible enough so that other people can, other people or you in the future can modify the code, can make changes to it, can fix bugs, can add new features, and so then languages have these style guides that say this is what idiomatic Java looks like, so that it's approachable to a bunch of people, and so then it's kind of like the style is kind of like the accent for the language, right? And so you can go to different parts of the country or go to different parts of the world, and people are speaking maybe a language that but because they're pronouncing words differently, because maybe they're putting words in different orders, you don't exactly you're not having the same kind of quality of conversation that you would have someone that speaks has the same accent, same idioms as you do. Your code's the same way. You want to make so I encourage you as you're learning about Java to read the Java style guide, the one produced by Google. This is kind of the standard these days, and it's more than just tabs and spaces or where your braces go and stuff. It really talks about the order of your program elements within a class. There's a little bit about naming in there also. It's good stuff in there. It's definitely worth a read. It'll help you write better Java, and better because other people will be able to consume it more easily. Finally, there's the dash readme switch for your project. And the whole idea is that this is another piece of documentation with your code that explains briefly what your software does. And so then when your project is run with a dash readme, all it should do is print a brief, concise, and nicely formatted description of what your project does, and then exit. Doesn't do anything else. No command line validation, no executing the command line, nothing like that. Just prints the README and exits. Please make sure that your README includes your name as well as which assignment it is. And it should be more than just command line usage. Here again, a sentence or two about what your program does. Yes?
So I see in the footnote it says that the README must be hard-coded in.
That is no longer true.
Okay. Because.
Yep. For many years I did that, and this time I'm like, you know what? I'm making you guys write unit tests and stuff. You can load a text file if you want.
Okay,
yep.
Yeah, I have a README as a resource.
That's exact. Yeah, that is now supported. Yep. Yep. So I should take that out. Thank you for the reminder. Yeah.
As far as the plan of attack goes, can you give a short example for maybe the students?
Yeah, so let's see here. For the student program, I'd probably say, for Project Zero, I'm developing a student class that has, these attributes on the number of classes and things like that. This is a pretty straightforward class, and here are a couple test cases that, I'm thinking of. I need to go research what the ArrayList class is because I can't remember, things like that. So you're right, and so like Project 0 and Project 1, pretty straightforward. By the time we get to Project 3 or Project 4, you'll have a much meatier POA, and my expectations will be raised in terms of the kind of questions that you ask. But really, so it's about demonstrating to me that you have a clue about how you're going to approach the assignment.
So it's sort of a kind of a personal assessment.
Yeah, maybe a little narrative, maybe a little like, oh yeah, here are the things, or like, oh yeah, right here. project one is pretty straightforward, and so then even just like listening, here are some test cases, or here are some conditions that that I'm interested in would be fine. Yeah, that's good. Good questions. Yeah. Anything else in documentation? Okay, so you've done all this work, and you've got all of your tests passing, and the code coverage is there. Now it's time to turn it in, right? You've written all the test cases that you can write, so therefore your code must be done. Here's how you submit. So, actually, how do you submit code in your other classes?
D2L. You zip it up in a tarball and drop it.
Okay, that's cool. And so you like actually like log in their website and like upload some zip file or whatever. Interesting. Okay, that's nice. I don't do that. So even though I have two graders, just one of me, and you know, like when I started teaching this course, I had like 18 or 20 students, and now I have 50 or 60. A big part of how I can provide the course to so many students is through automation. And so one of the things that I've automated is the project submitting process. And it's not so much automation for your benefit as it is for my benefit. And so I wrote a program that basically will take your source code, put it into a jar file or a zip file. I guess it's a zip file these days. Email it off to the grader's account, and then I also have code that will go and extract the zip files from those emails and then make it really easy for me to grade. And so a big part of that then here is for you to use the submit program. So this is a program that resides on the PSU machine. So again, I grade your code on the PSU machine. So I want you to write the code. Sorry, I want you to run your code before submitting it on the PSU machines, and then you submit it using the grader jar also. When you submit, there's some information I want. I want the name of the project, project 1, project 2, etc. I want to know who you are, what your login ID is, what your email address is. And then you also specify, hey, here's the source directory that contains my source code to submit. And you submit all of the source code that you write. So you're going to submit your main source code, your unit tests, and your integration tests, which we'll see shortly. There are some options here if you need them. So here's an example for submitting project 1. So I have my project 1 source code, and I run the program, and I give it the project, who I am, my ID, my email. If you want to have a comment, you can, and then the source directory. And so this would be the same as the source directory here. It's here for your airline. So what it'll do is it'll recurse this source directory, look for Java files, it'll look for XML files and text resources, I'm pretty sure. That's new this term, so I haven't exercised it very much. And it'll zip all those up into a jar file and send them off to me. And you'll also get an email receipt saying which files you were sent. And this counts as your submission, and of course I use the timestamp then on the email. Actually, there's a timestamp in the jar file. To tell me when exactly things were submitted. There are some notes here. So I only want source code. I don't want any compiled artifacts. I don't want class files. I don't want anything else in the target directory. As a matter of fact, the submission program will not submit anything that is not a Java XML or text file. And as a matter of fact, let's see here. Right. You can't submit POM files, which means that you can't add third-party libraries. So one of the questions that always comes up is like, we're doing command line parsing. Can't I use some third-party library for command line parsing? If this were the real world, yes. This is not the real world. Part of the assignment is parsing the command line. Yes, I know. That's kind of tedious. That's part of the assignment. Yep. So you can't add more libraries. Let's see here. If you followed the Getting Started repository and created your Maven projects and stuff, this will be taken care of for you, but I want to stress that the submission tool verifies that your source code directory structure is correct. So everything must reside under edu pdx cs410j, your login ID. Let's see here. If you go and get a copy of my source code and try to, so this is the stuff in like abstract airline and abstract flight. If you try to change it for whatever reason, I don't know why you would do such a thing. Maybe to make it easier, I don't know. You can't submit that back. If you try to do that, the submission program will reject it. Please make sure that your code compiles and that your tests run before you submit it. We're not going to debug your code for you. If something doesn't compile, and people sometimes forget things, or they make a change and forget to run their test in their build before it, it'll just get booted back to you. And the first time, I understand mistakes happen. I'll ask you to resubmit it. Usually it's, and then people will fix it and return it. But if you don't, your assignments are graded on how they run, not how beautiful your code is or not how clever your code is. Does your code run? And so then if your code doesn't even compile, you're not going to receive a good grade. Yeah. Please submit all of your files in one email. Don't run the submission program for like every individual file. I'm just going to throw that back at you and say, no, please run it with the source directory and get all of your code. Let's see here. You can submit multiple times before the due date. I get it, right? It's like, oh, you think everything working, and then like wake up at 3 in the morning. It's like, oh my gosh, I forgot to test this. And you realize there's a bug. That's cool. Go ahead and resubmit it. But realize that every time you do, the grader will have to unjar it. Actually, usually I do this, so I'll be the one unjarring it and extracting everything. So please don't waste anybody's time. Again. The late policy we covered in the syllabus, and we know that it's late because a submission has a timestamp on it. And if you're having problems submitting, you can try running with some of those options, but of course, reach out to me on Slack. Actually, reach out to the general channel or something, and let me know they're having a problem on the PSU machine. Actually, it says, don't try to run it on your own machine. The SMTP servers have gotten much stricter about where incoming requests come from, and so I don't think I haven't heard of anybody. I don't even test this anymore, so I should probably take it out of the handout. Any questions on submitting? Yeah.
Does it print a little confirmation when you run
It prints confirmation and sends you an email with like, oh, here's what was submitted. So you've got a paper trail also, and so you can look at the email and say, oh, yep, good, I got all my files. Or it's like, oh no, I forgot my resource file or whatever. But if you just give the name of the directory, it'll recurse. Yeah.
And for the directory, so you'd have like on the Linux machine, edu/pdx/cs410j/id/project1.
Yeah, that's the name of the file, but actually all you need on the command line is just the top level directory. It'll recurse into subdirectories. The note there is just making sure that that your package name is correct, because when I compile it and run it, I expect your package to be edu pdx cs410j, your login ID.
So it does, like on the system, we don't actually have that record or that record.
Do. Yep, right. Like in your GitHub repository, you've got that. So it's a source main Java edu pdx cs410j. What are we now? cs410j, your login ID. Because you ought to, right? You're looking. Like if you look at project1.java class, it should be in a directory structure that is all those directories.
It does not.
Really? Okay. Well, we can talk afterwards then. Make sure it. Okay. Any questions on submitting? Okay. Finally, let's talk about Project 2. Okay, in Project 1, you develop your fundamental Java classes, your flight, and your airline. And as some of you have probably noticed, you don't do too much with them. You run the command line. The command line parse. You parse the command line. You create the flight. You add to an airline. Maybe you print it out. Maybe you don't, and then that's it. Right? The first question a lot of people ask is like, wait a second, can I save it? It's like, nope, not for Project 1. Project 1 is just simple stuff, making sure that you can just write some Java code. Project 2 is where things start to get a little bit more interesting. So now in Project 2, you're storing your airline in a text file. And this is due, let's see here, in 2 weeks, February 29th, right before class. No, January 29th, right before class. It's leap day in January. So you'll write some classes that allow you to store and retrieve and fetch an airline and its flights from a text file. And the format of the text file is completely up to you. It's part of the assignment. Design a format for a text file that you can write out and then read back in again. And what it's intended to teach you is how to use Java's I/O facilities. And so this is all covered in the lectures online. So there are three new classes that you'll have to implement for this assignment. And I don't believe you shouldn't have to change any of your code for Project 1, any of your airline or flight code for Project 1 in order to do Project 2. The first new class you need to implement is something called Text Dumper. Text Dumper implements an interface, one of my interfaces, called Airline Dumper. That takes an airline and writes it to, in this case, a text file. So both the airline and its flights. Text Parser goes the other way. Text Parser reads, an airline parser reads from some source and from it produces an airline. So your text parser will read the contents of that text file that you wrote out and then create an airline from it. Project 2 drives this whole process, and its main method reads the command line. If a text file is specified on the command line, it'll create an airline. It'll read an airline from that text file. It'll add a new flight to it as specified on the command line, and the flight information is exactly the same as in Project 1. And then it'll write the airline back out to the text file. So here's the command line. The command line looks the same, at least all the arguments are the same as in Project 1. But there is a new option called text file, and this is the place to read and write the text file from. Now, it's very important to note that if the text file does not exist, it's not an error. Your program should not exit. Instead, if the text file doesn't exist yet, then you create a new one, right? Because otherwise, how would you bootstrap your program, right? You've got to say, okay, well, text file doesn't exist. That's cool. I'll create a new empty airline. I'll add the flight to it, and then I'll write the airline with that flight out to that text file. Oh, kind of a fun thing that I've added, and fun is what I think fun is. There's a parameterized type in the dump method of the airline dumper, so you get to play with Java generics a little bit and figure all that out. If things don't compile for you, feel free to reach out because it's a little bit of an advanced topic, but it's a good way to sort of teach you how generics can be used. So if something goes wrong while your program is running, it should exit gracefully with a user-friendly error message under situations such like your command line is missing something or you have extra arguments on your command line. If the format of the day or time is incorrect on the command line. If anything about the text file is malformed, right? So I'm going to give you a heads up right now. One of my test cases is I take your text file, I make some changes to it, and then I send it back to your program to see what happens. If it gets like a null pointer exception, not so good. But if it says, hey, listen, your text file is malformed, that's much better. And then another thing is it's an error if the airline name given on the command line is different than the one found in the text file, right? So you should only, you can't write one airline's flight to another airline's text file. So that's Project 2. Builds incrementally on Project 1 by giving you an opportunity to learn about and work with Java's I/O APIs. Any questions about that? 2 in 2 weeks? Seem good? Mm-hmm. Cool. I'm kind of sweating the recording here, so I'm going to stop the recording and just take a little break. Let's take another 10 minutes. And then we'll come back and we'll learn about integration tests and how to exercise the command line from automated tests.